Alrighty, good afternoon, everyone, and thanks for being with us for our latest NPA weekly webinar. My name is Sam Johnson, and I'm involved with NPA on.
Sorry, Sam, just going to interrupt you there. I've got a little bit of problem with the sound. It's just cutting in and out a little.
What about now?
Yep, okay.
Bit better?
Yeah, that's better.
Okay, thanks. Like a little bit of a test run. Hi, everyone. My name is Sam Johnson. Good to be with you all. I'm involved in NPA with the Urban Bushland and Waterways subcommittee, and as part of we have a slot once a month where we bring together all of us to talk about a different topic of relevance in urban bushland and waterways. And this month, we're going to be talking about the issue of turning down the heat in Sydney. And as we all know, Sydney is getting hotter. We're coming into summer, and this is something that's quite important to a lot of you, and you'd like to learn more about why Sydney is hot and what changes are happening for the future, and what as citizens and as government and industry can do to put Sydney's temperature on the right path. We're very glad to have with us today a number of people who are working in research and in industry and with government who are going to take us through a couple of presentations. So first of all, we're going to be hearing from Professor Matt Santamaris, who is a professor of high performance architecture at the University of New South Wales and has many decades of experience looking into solutions and the state of the art when it comes to urban heat. Professor Santamaris is going to take us through the lay of the land on the latest in the state of the art. And then after that, we're going to move on to looking to practice and hear from colleagues Judith Drinsma and Kelly Gee from the Western Sydney Regional Organisation of Councils Turn Down the Heat Strategy and Implementation. And it's really exciting to have the two of you here with us today because we know that Turn Down the Heat is one of the most mature, coordinated and needed urban heat initiatives in Sydney. And for those of you who aren't familiar with the Zoom webinar arrangement, we've got two functions whereby you can raise questions to the panelists in the Q&A button you see there at the bottom of your screen. And then next to that, for other more general comments, you can use the chat function. And I'll be keeping an eye on those, and we'll have a curated Q&A session towards the end. But I'm going to hand over now to Professor Santamaris to start us off and give us some background into urban heat and some possible actions we can take to do something about it. So thanks very much, Professor.
Thank you very much, Sam. Thank you very much for the invitation. Just to share my screen. Can you see my screen now?
Yes, we can.
Good. Thank you. Thank you so much. So we will discuss about the problem of overheating in Sydney, the potential mitigation, that we may apply, and also the results of, let's say, mitigation. First, allow me to say that urban overheating is one of the most documented phenomena of climatic change. And in general, climatic change, regional climatic change and urban overheating has to do with, let's say, much higher temperatures at the center of the city compared to the surrounding suburban or rural areas. And this is because of the high anthropogenic heat, which is released in the center of the cities, or because, of the very high storage of heat because of the, let's say, absorbing materials. This is, as I mentioned before, a very well-documented phenomenon. We have experimental data from more than 500 cities all around the world. And in this screen, you can see the magnitude of the urban overheating in about 110 Asian and Australian cities. with an average, overheating of about 5 degrees, but there are many cities, mainly in Asia, with an overheating magnitude close to 10 degrees. So it's a very, let's say, important and serious phenomenon. But urban overheating is not just the increase of the temperature of our cities. It has to do also with the increase of the duration of hot spells. If we try really to, let's say, analyze the length of the hot spells above 37 degrees, and this is the red spot, between, let's say, 80, 90, and in our days, you will see that there's a tremendous increase during the very last period. But also, it is very much related to the increase of the magnitude and also the frequency of extreme events, of extreme heat events, heat waves. As you can see, for example, during the very last years, there's a tremendous increase of, let's say, the frequency and the magnitude of heat waves. So urban overheating, and not just heat island, it is a very complex phenomenon that has to do with higher temperatures, let's say more, let's say extended duration of hot spells, and also higher magnitude and frequency of heat waves. What about Sydney? Sydney suffers from, let's say, a continuous increase of temperature, and you can see the sequence of the temperature increase in January between, let's say, 1970 and our days. There is a very important average increase of the temperature, which is caused partly by, let's say, urbanization, industrialization, but also global and regional climatic change. Oops, I'm sorry. And let's start to analyze a little bit what is happening in Sydney. Trying to understand really the characteristics of urban overheating in Sydney, first we have to start from, let's say, the distribution of the wind speed in, let's say, the city. The city is characterized by two synoptic, meteorological, or climatologic conditions. We have the eastern, let's say, synoptic conditions, which are associated with the sea breeze, which is, let's say, wind coming from the sea and cools down the eastern part of the city. And you can see, for example, the magnitude of the wind. And this, wind is going up to the eastern part of Parramatta. And we have, unfortunately, a second synoptic system, which has to do with western winds coming from the desert, which affect very much the western part of the city. So this is the main reason of the overheating. Overheating in Sydney is not because of the lack of greenery. It's not because of the very high anthropogenic heat. It's because of the synoptic system we have from the western part, let's say, of the country, and especially from the desert. Overheating in Sydney is because of the very strong, let's say, advection coming from the desert. And every solution that has to address the problem should really decrease the strength of the advection. On the other hand, if we try really to understand the distribution of the surface temperature in Sydney, you may realize that part of the Sydney really is characterized by high surface temperature. Why this happens? Because we are using non-proper materials. Because we are using very absorbing materials in streets, in pavements, in roofs, in buildings, which absorb heat and also emit this heat, and through convection increase the temperature of the city. And as a result of the combination of the wind speed distribution and the distribution of the surface temperature, we have this specific, let's say, distribution of the ambient temperature during the summer at 2 o'clock in the afternoon, during, let's say, a hot day, where you can realize that there is a very important temperature difference between the eastern suburbs and the western suburbs that really may be as high as 9 degrees. But I repeat, the main reason behind, this temperature difference is the advection of, let's say, wind from the desert that increases the temperature in the western part of the city, and also the advection of cool air from the sea breeze that decreases the temperature in the eastern part, and so increases the temperature difference between the eastern and the western part. If we try to analyze on a year basis the temperature distribution in the city, you will see, for example, that the temperature in the eastern Sydney, in the eastern part, in the coastal part, ranges during summer between, let's say, during night 18, 19, 20 degrees, and let's say 30, 32 degrees during the, let's say, the daytime. But in Western Sydney, maximum temperatures may be as high as 35 degrees average maximum temperature, or in the area of, let's say, the very western part, Southern Creek, maybe 35, and in Penrith, which with Richmond are the hottest part of the city, temperature may be as high as, let's say, 36, 37 degrees. And you know very well that we have absolute maximums approaching 50 degrees. In average, in Penrith, we have an increase of the maximum temperature about 0.4, 0.5 degrees per year. This is what really happens actually in Sydney. And trying really to understand the phenomenon, we have to, let's say, make it clear that this is not just a regional phenomenon. It is very much connected, associated with the global climatic change. If you try really to analyze the magnitude of the overheating of the temperature difference between the eastern and the western part during, let's say, extreme events, you will realize that during this period, heat waves, the temperature difference is increasing by 5 degrees. And you can see that in this graph. Why this happened? Because regional climatic change, local overheating, is very much affected by the global overheating. And why this happened? Because during, let's say, the hot days or during the heat waves, we have a much higher advection coming from the desert. And why we have a much higher advection? Because the so-called Rossby waves coming from the equator towards the pole are really more humid and are really passing through the desert and creates really some stagnant pressure differences between the coast and the desert. And this brings hot air into, let's say, Western Sydney. So the problem of overheating in Sydney is a complex problem that is very much related to global climatic change and is not just a local problem that can be solved with just local, let's say, measures. What about the future? There are many studies trying really to forecast the future climatic conditions in Sydney. And most of the studies, or almost all studies, they agree that there will be an important increase of the temperature in the city. And you can see, for example, that we expect that the temperature in the eastern part will increase by 2 or 3 degrees, but the temperature, you know, or the average temperature in the western part of the city may increase up to 4 or 5 degrees. And this is, let's say, an agreement between all the existing scenarios for, let's say, Western Sydney or the whole city of Sydney. This is what is happening regarding temperatures and the distribution of temperature. What about the impact of the overheating? It is obvious that higher temperatures affect the energy consumption, affect health, affect the environmental quality, affect sustainability and vulnerability, and the economic activities. Do we have enough knowledge about the impact of climatic change, global and regional climatic change in Sydney? Yes, we have a lot of data. As it concerns energy, we have really to make clear that higher temperatures affect very much the demand of energy, especially of the energy for cooling, but affect very much the, let's say, supply of electricity. Because of the very high temperatures, utilities have to build additional power plants to satisfy the demand, and this happens just for 1 or 2 months per year, which means that the utilizability of the additional power plant is low, which means that the cost of electricity is increasing tremendously. On the other hand, because of the higher temperatures, the efficiency of the power plants is increasing also very much. Do we have enough quantitative data about the impact of urban overheating concerning the additional energy we have to spend? Yes. This is very well estimated by several studies. In average, the global energy penalty per square meter of city is 2.3 kilowatt hours per square meter, or the global energy penalty per square meter and degree of temperature increase is close to 0.7 kilowatt hours per square meter and degree, or if you like really to translate it into the global energy penalty per person, it is close to 230 kilowatt hours per person. So each one of us is paying 230 kilowatt hours per person because, as a penalty, because of the overheating. But is it the same everywhere in Sydney? Not at all. If really we try to, let's say, plot the distribution of the energy demand, and especially cooling demand in Sydney, you will see, for example, that in the northwestern part of the city, the energy consumption of a residential building is to about 100% higher than the energy consumption for cooling of exactly the same similar building in, let's say, the eastern part of the city. We are performing now the mitigation study for Sydney for, let's say, the Department of Industry, and we have simulated with a resolution of 500 meters by 500 meters for the whole Sydney, 17 different types of buildings, and the same thing happens, for every type of building. So there's a tremendous energy penalty because of the overheating in Western Sydney. What about, let's say, the energy consumption we expect in the future? Once really we calculate the future energy consumption, given the actual climatic data, you can see, for example, the, let's say, in the upper part, the energy consumption for cooling, which is the red part, and the energy consumption for heating, which is the green part. And in the lower graph, you see the expected energy consumption for cooling in 2050, which means 3 times higher than today, and the energy consumption for heating in 2050, which is going to be the same, not really lower. This is about energy. What's about the environmental impact? Unfortunately, because of the higher temperatures, we face an important increase of the concentration of ozone in the city, because you know that ozone, and especially ground level ozone, is a byproduct of, let's say, photochemical reactions, which are really catalyzed by the higher temperature and many other things. The increase of the ozone, which is a killer, in Sydney, it happens at a proportion of, let's say, at the percentage of 87% during, let's say, the period of, let's say, high temperatures. But unfortunately, it's not just that. All the data we have, it shows that the efficiency of our power plants, especially the thermal power plants, those using coal or gas or, oil, but we don't have oil systems here in Sydney, decreases by a factor of, let's say, 3.6% per degree of temperature increase. So during a day, that temperature may increase up to 10 degrees during a heat wave, the efficiency of the power plants is decreasing by 30%, which is a tremendous, really, let's say, decrease of the efficiency of the systems. Unfortunately, the energy and the environmental, let's say, impact is not the most important. We know very well that overheating is affecting very much low-income population. And because low-income population is living in houses of low environmental and energy quality, no insulation, no double glazing, not well, let's say, protected, the first victims of temperature increase is really the low-income population and the low-income households. Do we have enough evidence? Yes. Last year in UNSW, we monitored 110 low-income households in Western Sydney, and I'd like really to share with you some of the results. This is done together with the local government of New South Wales. We were very surprised to see that during the winter period, indoor temperatures were as low as 7, 8, 9 degrees for most of the houses, but during the summer period, not during a heat wave, indoor temperature was as high as 40 degrees, not during a heat wave, for more than 4 or 5 days, let's say, during the summer period. And you can see the sequence, of the temperature in these 110 houses. So there's a very serious problem of overheating in Western Sydney, especially in low-income households. But unfortunately, it's not just that. People, in order to be protected, they close all the doors, they close all the windows, and this increases tremendously the concentration of carbon dioxide. So the concentration of carbon dioxide during the monitoring was 4 times higher than the threshold set by, let's say, the actual Australian standards. So imagine that these people, they live close to 40 degrees indoor temperature with 4 times higher CO2 concentration, which is really a very, very, let's say, dangerous condition of life. And then this brings us to the very important problem, of, let's say, health. And there are a lot of studies actually carried out in, let's say, Sydney, trying to associate urban overheating with health. But before really present you some of the results, I like really to stress something that really is coming out during the very last period, that while the risk of urban overheating of higher ambient temperatures outdoors are quite high, the risk of low quality housing is 3 times higher. So the risk of, let's say, heat-related mortality. The combination of high outdoor temperatures with, let's say, low quality housing is really a very important and very serious, let's say, condition that may kill a lot of people or already kills, a lot of people. And based on existing standards and existing studies, we have calculated the distribution of the heat-related mortality in Sydney during, let's say, heat waves or during the hot period. And you can see that during these days, heat-related mortality in Western Sydney may be as high as 3 times higher than Eastern Sydney. And during, let's say, a hot wave day, I'm sorry about my slides and my emails, you can see if we compare the heat-related mortality, calculated heat-related mortality in East and in Western part of the city during the same day, that in Western Sydney is 3 times higher. These are calculated values, but working with the city of Parramatta, we have collected all the real data from the Department of Health for about 20 years. We have performed the same study with basic real data, and I'm afraid that the same situation and the same real figures have been concluded. What about the future mortality? Actually, there are many scenarios about future mortality in Sydney. And I like just to show you some of them. In my graph, in this part here, it is the actual mortality in the eastern part of the city. This is the actual heat-related mortality, the second in the western part of the city. All the rest are scenarios about heat-related mortality that have to do with the different global climatic modeling, the future climate in Sydney, and the actions we may, let's say, have proactive or reactive actions in order to improve the environmental quality. We may expect a tremendous increase of the heat-related mortality in Sydney, and I hope this will not be the case. But in case that really we take measures, proper measures, then we may decrease, the impact of overheating and let's say keep it as it is now or have a little bit, of higher mortality. These are the bad news. So this is the situation. Do we have good news? Can we improve, let's say, the climate and the conditions in Sydney? Yes, of course. During the last 15 years, there are a lot of, let's say, serious scientific research carried out all around the world, trying really to, let's say, develop advanced mitigation technologies and adaptation, but mainly mitigation technologies based on different technologies, aiming to decrease the temperature of our cities. there are more than, let's say, 400 large-scale projects all around the world where mitigation technologies have been applied, implemented, and will have results. Two are the main, let's say, technologies that have been developed during the very last years. The very first one has to do with the development of the so-called, let's say, cool materials, or recently the very super cool materials. And we started 20 years ago with white surfaces, and gradually through the development of very advanced technologies, let's say the super cool materials, now we are able to decrease the temperature of our cities, the peak temperature of our cities, up to 2.53 degrees by using, let's say, these materials. I like to point out that in UNSW, we have developed the super cool materials, tested last summer, December, in Alice Springs, outdoor temperature 44 degrees, under the sun, 1000 watts, the temperature, of the materials was 25 degrees, about 20 degrees lower than, let's say, the ambient temperature without any use of, let's say, energy. It's a natural air condition. These super cool materials that we have developed are now applied in major international projects. For example, we're responsible for the project of Riyadh in Saudi Arabia, in Kuala Lumpur, in Malaysia, in Kolkata, in India, in Dubai, in Arab Emirates, in Mombasa, in, let's say, Kenya. And we started the application also of these new technologies in, let's say, Houston in the United States. So what about, let's say, the potential use of greenery in, let's say, in Sydney? There is a policy to plant 5 million trees let's say, of trees in Sydney. We have performed for the Department, let's say, of Landscape and the regional government of New South Wales, detailed works trying really to understand the impact of the 5 million trees, and trees may decrease the peak temperature of cities, of the city, and especially in Western Sydney, in, let's say, 5 million trees during a whole day up to 1 degree. This is what we can expect. There is much higher, let's say, decrease of the temperature during the night period. And this is the temperature distribution and the temperature decrease we may expect once really we use such a technology. And this is really important. But the most important thing is that the use of greenery and the use of materials, everything that decreases the surface temperature of the city decreases at the same time the so-called planetary boundary layer, which is the layer where the air is circulated. And by decreasing in Western Sydney the PBL, the planetary boundary layer, we really stop the advection of the wind coming from the desert. We close the door to the western winds. So by using low surface materials and greenery in Western Sydney, we really decrease tremendously the advection of heat from the western part, of the country. And this is the more efficient technique really to decrease, let's say, the overheating in the city. On the contrary, once we are using such, let's say, techniques in the eastern part of the city, in the coastal areas, we decrease the strength of the, let's say, the sea breeze, and unfortunately, we increase the temperature in Western Sydney. So it's not appropriate all over the world, this is very well known, to plant trees, in the coastal areas, because really we decrease the strength of, let's say, the sea breeze. On the other hand, it is very important to understand really which is the impact of, let's say, the lower temperature on the wind speed. And you may understand that by having, let's say, such a policy or such a mitigation, let's say, strategy, we may have a tremendous decrease, and you see the simulation of the let's say, wind speed in Western Sydney coming from the desert, which means a very important, really, decrease of the advection and a very important decrease of the strength of the overheating. And this is what really we may expect. What has happened all around the world? We have monitored, because we are responsible for more than 200 projects of mitigation all around the world. We have really reviewed more than 70 different projects all around the world, real projects, where really the implementation of greenery, of increase of the green infrastructure has been monitored, real data. And from this, let's say, graph, you can see that during the day, which is the lower, let's say, line, this one here, the increase of the decrease of the peak temperature maybe, let's say, is a function, of course, of the increase of the green infrastructure, but it is of the order of magnitude of 0.4, 0.5 degrees, 1 degree the maximum. And this is very much really associated with the irrigation of the trees. There are cities where plantation of trees, which are not well irrigated, have resulted in an increase of the temperature. For example, in Los Angeles, the use of additional greenery, not irrigated greenery, has increased the temperature in specific zones up to 1.5 degrees. These are measured data. On the contrary, and the same in, let's say, in Dubai, the same in Qatar, and the same also in Riyadh, in Saudi Arabia. On the contrary, the use of greenery during the night period shows a very important mitigation potential, which may go up to 1.5, 2 degrees, which really is very important and may help a lot really to decrease, let's say, the temperature of our city. This is the real potential. I heard, I'm sorry to say that, several people saying that by planting trees, we may decrease temperature 2 or 3 degrees. This never happened all around the world. The other thing that is very important and has to be, let's say, well understood is that trees may, let's say, produce heating over a certain threshold ambient temperature. Why? Because they like really and they wish to keep their sap protected. So once the temperature goes higher than a threshold ambient temperature, trees do not stop to evapotranspirate, so no cooling, and because their leaves are of dark, let's say, color, they contribute into heating. And this is the reason that during heat waves, the very last 10 years, we know it, during, let's say, heat waves, inside parks, temperature may be much higher than the temperature outside parks. We perform very specific measurements of several trees in Western Sydney. And we measure the sap, the evapotranspiration provided by the trees in, let's say, in Western Sydney. And this is the graph that shows really how is the sap. And you can see that trees above a threshold temperature, you know, which in our case is for eucalyptus 32, 33 degrees, trees, they stop really to evapotranspirate to keep really their sap. And in this case, you know, they don't provide any cooling. The only way to provide cooling is to have a lot of irrigation and in order really to increase their sap. So most of the actual simulations carried out in Sydney and in most of the Australian cities do not consider this new effect that we learned during the very last years because we never had such high temperatures. So we have performed new simulations for the government, trying really to understand which is the impact of this, let's say, specificity of trees during, let's say, high temperatures. And these are the results considering or not considering the, let's say, impact of reduced sap during, let's say, high temperatures. As you can see, during, let's say, the peak hours, the actual models, they overestimate the mitigation potential of greenery up to 3 degrees because, you know, this is not taken into account. So we have always to consider that once we are using additional greenery, we should irrigate this greenery. We have performed simulations and we've seen that in order really to support 5 million additional trees in Sydney, we need really to increase the water consumption in Sydney by about 14%, which is really very high. The other issue that has to be considered once really we plant trees is the additional, let's say, pollution. We know very well that most of trees, they, let's say, emit BVOCs, and some trees, like eucalyptus, they emit BVOCs, which are 4 times more toxic than the exhaust of cars. So this is something that we have to take seriously into account. We have performed simulations trying to see what really is going to be the increase of, let's say, the different pollutants once really we plant additional trees, irrigated or not irrigated. And we have seen that really there is a very serious risk to increase, let's say, the concentration of some of the pollutants if not the proper trees are taken into account, and if there is no a scientific approach in the way that really we, let's say, use greenery. What about the impact of additional greenery and additional mitigation? Simulation shows that, as I showed you before, that if nothing happens by 2050, the energy consumption of our buildings will increase by a factor of 3. But if really we apply proactive policies and we have, let's say, and we apply and implement additional mitigation technologies plus additional adaptation technologies, better buildings, we may minimize even close to zero carbon, let's say, buildings by 2050, despite the climatic, let's say, increase, the climatic crisis, the climatic change, and the increase of the temperature. So these are the good news. We may, let's say, have much better indoor and outdoor environment if really we are using proactive policies that helps really to decrease indoor and outdoor temperature. The other good news have to do with health. Recent research that we have carried out in more than 100 real, let's say, large-scale projects all around the world have shown that the increase of the albedo, cool materials or super cool materials in cities, decreased tremendously the heat-related mortality by about, each decrease of, let's say, the albedo by 0.1 decreases heat-related mortality by 1.8%, and these are not estimations, these are real data from a very high number of cities, and almost the same happens for greenery. So by having, let's say, more appropriate greenery and more greenery, we may, let's say, save a lot of lives. So I'd like to conclude. We have a serious problem. Overheating is of the order of magnitude of 7, 8, 9 degrees, during the whole period, and may increase much more. Why? Because of the advection of heat from Western Sydney, and because of the global climatic change. Never forget that the problem of overheating in Sydney is not an isolated problem. It's very much related to the global climatic change. Whatever we are doing in Sydney, if climatic change in the tropics or in the equator is increasing, Sydney will be very much affected. Unfortunately, climatic change, regional climatic change, has a very important impact on energy, is increasing the energy consumption in Western Sydney up to 100%, is increasing peak electricity demand by 10%, which means that they have to plant let's say, to use more power plants and install more power plants, which increase the cost of electricity, and also has a very serious impact on heat-related mortality. The good news, because of the very important scientific research carried out during the last 10, 15 years, and a lot of research has been carried out in Australia. Australia is one of the leading countries on mitigation. We are able to decrease the temperature of our cities, the ambient temperature of our cities, up to 3 degrees now, and in the near future, 2 or 3 years later, up to 5 degrees. We have data from more than 250 large-scale mitigation projects all around the world, where really we have found that we can decrease the temperature of the cities up to 2.53 degrees. We have to be very careful to apply scientific approaches. Empirical approaches, which do not take into account the recent, let's say, science, may lead into an increase of the temperature, and this happens in many cities. So it is very important that any action taken, in the country or in the city is really taken by people that they know the scientific, let's say, they have the scientific knowledge and they understand really, and they have the knowledge of what's happened all around the world. The impact, we may decrease the energy consumption of our cities or of our buildings up to 40–50%. This is very clear from the cool roof mitigation study of the Department of Industry that we saw some days ago. At the same time, we may have a very important decrease of the peak electricity demand up to 4–5%, which means less power plants, less cost for electricity, and the most important, we may have decreased the peak, let's say, of the heat-related mortality during the peak up to 35%. Thank you so much.
Thank you so much, Professor, for that really interesting and eye-opening presentation, and truly showing us that.
I can't hear you.
Can you hear me now?
Yes.
That's good. I was just saying thank you very much for that, and showing us that really the devil's in the details when it comes to thinking about urban heat in Sydney. And in the interest of time, I'm going to move straight on to hearing from Judith and Kelly from West Rock, but then at the end we'll come back and we'll take questions from the audience on your presentation, Professor. So I'll hand over to you, Judith and Kelly. Thank you.
Great, thank you so much, and thanks also for the opportunity to present today. And it's always fantastic to hear Professor Santamoros talk about this issue. And I think, like he's demonstrated, when we talk about heat is really complex when you go into the detail. The good news is that heat has been recognised across a lot of policy domains for Sydney, and there's a lot of action happening, implementing a lot of fantastic projects that we wanted to touch upon today. However, I also absolutely acknowledge that there seems to be a bit of a lag in terms of all the science that we've got, but then translating that into actual policy on the ground and getting results on the ground. Anyway, today we'll talk a little bit about some of the work that we've been doing and our stakeholders. Just for those of you who don't know us, so I'm Judith Brinsma, project coordinator at West Rock. West Rock represents councils across Western Sydney, and we advocate and implement projects on behalf of our councils. So as Professor Santamoros already sort of pointed out, heat is a particularly issue for Western Sydney. It particularly impacts Western Sydney, and that's, I guess, where West Rock sort of became involved in assisting councils, but also working with a whole range of other stakeholders to address this issue. So underpinning pretty much all of what we do is a resilience approach. So if we can go to the next slide. So what we try to recognise based on the research from Professor Santamoros and others across Australia and elsewhere is that while urban heat can be mitigated to an extent, some of our populations will still need to deal with really extreme temperatures, and we need to make sure that our people can stay safe and comfortable and also healthy in a warming climate. But we also need to make sure that we've got our response in place in case things go badly wrong, like when we do hit those 50-degree temperatures and we get a power outage. What do we do? How do we respond in an emergency event like that? So that resilience approach that you can see on the slide now, that really sort of steps through sort of key things to really think about heat in a more sort of holistic way. So it talks about the need to assess and understand vulnerability and risk conditions in a place, in a neighbourhood or a street. The reduce bit talks about the need to really design buildings and places to reduce average temperatures as much as we can. So that's that mitigation part that Professor Santamoros really talked about. But then we also need to adapt, so making sure that we manage that residual exposure to heat through building a place design that keeps spaces comfortable and safe. And again, like I said before, we need to recognise that adaptations won't address all exposure, but we also need to implement contingency measures to help, especially those most vulnerable. So we need to sort of think about cool refuges and the likes. So if you look at the next slide, I won't go through this in a lot of detail, but it just shows, it's just here to reiterate again that What is required is an integrated approach to heat wave management. So we need to make sure that we've got the governance in place to coordinate action. We need to be clear on responsibilities. We need to ensure that we collect the right data for risk assessment and monitoring. And like Professor Santamoris rightly pointed out, I think we can do a lot better in that sense as well. And because some of the data and temperature data we're collecting, like through the BOM, they're just not fit for purpose. They actually don't show what's happening on the ground and what people are experiencing. We also need to ensure that we've got those policy settings right to deliver the actual outcomes on the ground, and we need to ensure that we upskill our people where required. So if we go to the next page, so I know there's a lot of information on here. These are just some of the projects that Westrock's currently implementing, and I might just touch upon a few of them. The key areas, I suppose, where we've done a lot of work is around sort of planning controls and place design and emergency planning and community resilience. I also do want to point out, like, while we talk about Western Sydney a lot in this presentation, both Professor Santamoris and us, we do recognise that heat is an issue that impacts other parts of the city as well, and also other parts of Australia. So I do think a lot of the work that we've been doing, also a lot of the research that we've sort of highlighted today, is probably of relevance to others across Sydney or across Australia. I also just want to acknowledge that pretty much for all of our projects, it's not just Westrock doing the work. This is a collaborative effort with so many stakeholders, including councils, state agencies, universities, industry, and community representatives. So just to touch upon a couple of the projects here on the slide. So we've developed the Turn Down the Heat strategy. That's our overarching strategy that was developed with people from planning, environment, health, community, academia, and industry. And it really sort of sets priority actions for implementation across the city. This strategy, all of the documentation, that all of the projects I'm referring to here, they're all listed on our website as well. So please feel free to have a look at that. And I think we've provided Sam with a few copies, and they can definitely be shared after this presentation, because I know I'm rattling off quite quickly here. Our Heat Smart Resilience Framework really looks at sort of that emergency response, and particularly looks around what governance structures are required to ensure that our city implements a coordinated response to heat. We've also developed a whole range of community resources which are currently actually being tested with communities, and we're running heat resilience workshops in partnership with the Red Cross and with New South Wales Health and our councils as well. We've done quite a bit in sort of the urban design and planning space. So we've got our Cool Suburbs tool, and we've got the Urban Heat Planning Toolkit. So both of these projects are really looking at guiding better design, better urban design for our cities. So Cool Suburbs is really out there to push best practice and provides guidance for both industry and governance. And the Urban Heat Planning Toolkit specifically developed for councils, and that sort of sits within the New South Wales planning framework. So both of these projects really talk about what better urban design is. So it talks about sort of what do we need for better greening. So yes, all the stuff that Professor Santamoris talked about, we need that irrigation, we need species selection, we need to create space for trees, but we also need to ensure that we keep water in our landscape, that we use cool materials, and all of the other things that were mentioned. So the Urban Heat Planning Toolkit is actually on our website, and it sets all of this out really quite clearly, I think, anyway. So feel free to have a look at that. Other projects, so just pointing to climate resilient street trees, again, that comes to the point that Max Santamoris made around the need to be very careful about the selection of your tree species, but also ensuring you've got irrigation attached to any sort of street trees that you do plant, and green canopy that you're trying to set up. Future-proofing residential development really looks at modelling how current compliant buildings how they would perform under future climate projections. So that comes back to that thermal comfort, thermal safety, and thermal survivability. Like, what do we need to change in our building codes to ensure that we can keep people safe? I might very quickly hand over to my colleague Kelly, who might sort of show you a few other projects that that are being implemented, not necessarily by Westrock, but by our partners.
Excellent, thank you, Judith. Yeah, so as we said, there's a whole lot of stuff happening, and I know it can be we get a bit depressed sometimes when we're thinking about all the challenges that lie ahead of us, but there is some really good work happening on the ground. So a few of the projects outlined on this slide, just to give you a bit of a taster of some of the things that are going on. So the first one on the top left there is what is called the Climate Adapted People Shelter at Penrith, outside Nepean Hospital. And this really looks at, I guess, some of the adaptations that we might need to make in our built environment. So this is really focused on protecting people from the elements while they're waiting for public transport. And it includes some insulated panels on the top and the sides to really do as much as it can to keep people safe during hotter weather. The one in the middle is a UV and heat safe playground for children. So there was recently a report released by Western Sydney University on the safety of children's playgrounds. Often they're made out of metal, which obviously heats up really quickly. And there have been a lot of instances where children have been quite severely burned due to the construction of playgrounds. And obviously that those materials are chosen for their durability, but in Western Sydney, quite a lot of the time they're far too hot. So working with Cumberland Council, Cancer Council and KidSafe, as well as the university, the council's prototyped a cool playground, which uses cool to touch materials. It includes shading, and it also includes tree canopy, but until that tree canopy establishes, that those shade sails will remain in place. Looking towards the emergency management end of the spectrum, Blacktown City Council is currently trialling a heat refuge strategy to set up cool places for people to visit during heat events and transport to and from. So that's really aimed at those vulnerable groups who may not have cooling at home. Down on the bottom left, we've had a lot of research from our councils looking at local microclimates and really detailed heat data so that they can target some of their mitigations to the areas that need it most. In the middle on the bottom there, we've got a cool roads trial where a few councils have trialled a cool light coating on some of their residential roads, which is shown to reduce temperatures significantly. And then finally on the bottom there, some of the examples of the kind of the first go at implementing urban heat mitigation into the planning system, which is really exciting to see. So I just wanted to round out here and be really quick around what all of us can do to, if we're really passionate about heat, like Judith and I, and I'm sure Professor Santamouris are. We really encourage, if you have the capacity, to get involved in government policy making and make submissions where you can, because often that community voice is missing. A lot of industry and a lot of government departments will submit, but not necessarily community. So there's a list of a few different upcoming submissions to keep an eye out for. And on the right there, I've got a few key points that we're making. The first is we really need to make sure we're building for future climates, not current climates, making sure we've got that resilience going forward. We need to look beyond greening. And when we do have greening policies, they need to be holistic, as Judith and Professor Santamouris have mentioned. And finally, looking at cost benefit analysis in a holistic way. So a lot of the cost benefit analysis we see is really looking at the economics and cost of development rather than broader societal benefits. The second point I've got is by leading by example at home. If you're doing renovations at home, think about lighter coloured or cool materials, think about permeability, think about greening and vegetation. And finally is talking to others. So this isn't on a lot of people's radar yet, and it's really good to let people know what they can do. But further, when we're looking at that emergency management end of the spectrum, it's really important to be in touch with your neighbours and to check in on others and make sure that they're okay, because social isolation has shown to be a really significant factor in mortality and some of those worse outcomes in relation to health. So I know I'm at time there, so I'll close off and hand back to you, Sam.
Thank you so much, Judith and Kelly. A really jam-packed presentation, and as you said, it can be sometimes a bit of a downer topic to talk about, but I think that the way you did it just then is very uplifting. It gives us some agency and thinking about what we can do going forward. Just looking to the Q&A, a few of the comments that had come through, I think they may feel that they've been answered by those last few slides. But I'm just going to go to the one we've got here from David Steve saying, what is the role of smart technology playing in monitoring urban infrastructure to adjust planning and response to increasing hotspots or peak events? And that's not addressed to anyone in particular, so please just come in if one of you would like a comment.
Just checking if Professor Santamorris wants to take that one, or whether you want us to have a go. I guess, yeah, so, oh, sorry.
Please, Professor.
Otherwise, we can have a go as well. And Kelly, jump in here as well. So I think that the problem that we are seeing with what we do today, definitely there is more of a role for smart technology, particularly around heat monitoring, etc. So like, I think I mentioned this, but currently even our heat waves are based on BOM data, but that BOM data, again, like I said before, it does not do justice to the actual impact of heat on the ground. So when a heat wave for Sydney, for example, might be called, some of Western Sydney might have been experiencing heat wave conditions for a long, long time already. So making sure that we have that finer grain detail in terms of temperature monitoring, and also attach our warning systems to it, and also noting, and I think Professor Santamorris flagged this as well, like when we do talk about health impacts of heat, it's not just a temperature either. We need to consider Kelly, moisture, not moisture.
Oh, sorry, I've been
humidity. Sorry,
humidity.
Yeah, we need to consider humidity as well. We need to consider duration. High temperatures during daytime or during the night have a massive impact, where high nighttime temperatures are actually more dangerous to people's health. So there's a lot to consider there. And so what Western is advocating for is to have finer grain sensors and temperature measurements, but also to potentially develop a better sort of warning system that takes into account all of those different areas, and that can provide more localized temperature warnings or heat wave warnings as such. I hope that sort of answers the question, but please, Matt or Kelly, add to that if I forgot anything.
I think I'm happy with that.
I'll ask a question to Matt, which was from Vlad, who was saying that he's surprised that urban trees in Western Sydney can help block out hot desert winds when we already have the Greater Blue Mountains. And he expected that any hot winds that pass the mountains would easily pass through all the planted trees in Sydney as well. Matt, would you be able to respond to that comment from Vlad?
Can you repeat the question? I'm sorry, I can't hear you very well.
Sure. So I was saying that Vlad has commented that we have the Blue Mountains to the west of Sydney, a large body of greenery, and the expectation was that would slow down or block out the desert winds to a very large extent, and that the effect of trees in Sydney would be perhaps marginal. Could you explain further?
Yeah. I think that let's say the greenery of the Blue Mountains is helping a lot. Otherwise, the degree of overheating could be much, much higher. It's helping a lot, but we have to understand that the transfer of heat is happening, at very high, let's say, heights. During in the PBL, I mean that it happens, at the height of about 300 meters, 400 meters, 500 meters, even higher. So it's not so much affected really by the lower circulation. It's very much affected by the upper circulation. And Yeah, so the impact is important, but it's not really very, very significant. What really will affect very much, the transfer of heat from Western Sydney, it has to do with, let's say, the decrease of the high of the planetary boundary layer, which means lower surface temperatures in Western Sydney. This is the most important issue. This is the best techniques to be applied. This is the only, if you like, technique to be applied if we really like to decrease the temperature in Western Sydney. We have to decrease the surface temperature in Western Sydney. Unfortunately, because of the increase, construction there, because of the increase let's say, infrastructure there, the temperature in the surface temperature in Western Sydney is increasing. And despite any measures we may take, this will have a negative impact.
Thanks a lot for that clarification, Professor. And I think that it, again, speaks to the fact that this is a complex space. And I'm very grateful that the three of you have shared your contributions and insights with us for this webinar. If I can, I'll get a copy of your respective presentations to share with our members if they want to get more information. But
yeah.
Is it a problem?
Interrupted, we hear some, just some words of what you're saying.
Thanks, Professor. Well, maybe that's a good time to wrap things up anyway, then, with these technical difficulties. I'll just say thank you very much for joining us. We really appreciate you taking time out of your day to do so. And we might see you again maybe next summer. Who knows?
When we've got all the solutions, right? Everything's in place.
Absolutely.
Thank you so much. Thank you so much.
Thanks, everyone.
Thank you. And thank you, Sam, for making it all happen in the background.
Thank you.